function domains. Okay, so our objective here, we want to find the domain. We want to find the set of x values that can go into a function. Find the domain of a function. What x values will the function accept? Well, we know what a function is. A function is a relation in which each component of the domain, which is the set of all x values or input values, corresponds to exactly one component of the range, which is the set of all y values or output values. Basically, it relates an input, an x value, to an output, a y value, by a rule. All right, a function's domain is the largest set of real numbers for which the output's values are real numbers as well. So we're going to be on a graph. This is usually all real numbers. So the domain of a function is usually from, whoops, I have this backwards, from negative infinity to positive infinity. I'm sorry, I have that backwards. A function's domain is usually all real numbers in interval notation, negative infinity to positive infinity. However, we need to be careful when dealing with functions that are fractions and or functions that involve even roots, which are usually our square roots, okay? Why do we need to be careful? Because fractions we cannot divide by 0. So any number that results in a 0 denominator is not a member of the domain. Even roots cannot take a negative. The radicand cannot be negative. So we cannot take the even root of a negative number. So any number that results in a negative radicand, which is the number under the radical sign, is not in the domain, okay? So we're focused on two things. We're starting off saying the domain is going to be all real numbers. However, we want to keep an eye out for a fraction or an even root, because these might restrict our domain. They may eliminate some possibilities that can go into the function. Let's take a look at some examples and see how this works. Okay, example 1, find the domain. Well, example 1, yes, we're doing ABC. So example 1, letter A, find the domain of this function x squared minus 7x. Well, we want to start off, and I'm going to write off here start. We want to start off by thinking, we want to be having our heads that the domain is all real numbers. Okay, so we start off here. Our domain is all real numbers. And then we say, do I have any fractions I need to be concerned about? Or do I have any even roots that I need to be concerned about? And in this first example, I don't have any fractions or even roots. Okay, so no fractions, no even roots. Okay, no fractions, so the domain is all real numbers. Okay, so here's where we ended up. We didn't change a thing. There's our domain. It's all real numbers. Whoops, I've already written that. So you don't need to read that. I don't need to write that again. There's our domain, all real numbers. Okay, from negative infinity to infinity, there is our number line that shows all real numbers. Let's do some couple other examples here. Let's take a look at some when the domain gets restricted, when there are numbers that can't go in the domain. So this function, g of x, is 3x plus 2 over x squared minus 2x minus 3. Okay, so here's our starting point. We're starting mentally. We're saying to ourselves, the domain is all real numbers unless I find something, okay, unless I find something I need to remove. Okay, so I'm starting here. It's a function, domain is all real numbers. Now let's look at it. Do I have a fraction and or do I have an even root? And here I have a fraction, numerator, denominator. And I know with a fraction, my denominator cannot equal to 0. So I notice I have a fraction, which tells me my denominator cannot equal 0. Well, when is my denominator 0? I got to pull those out. So let's look at my denominator, which is x squared minus 2x minus 3. When is it equal to 0? Well, this particular quadratic is factorable, and it's factorable as x minus 3 times x plus 1 equals 0. So I have here x minus 3 equals 0 or x plus 1 equals 0 using my zero product property. So when x equals 3 or when x equals negative 1, my denominator is 0. Okay, so I'm going back to my number line. And I'm saying I got to take out negative 1 because when negative 1 is x's value, the denominator is 0. I got to take out negative 1 from my domain. Negative 1 doesn't work. It will not give me an output value. I also need to remove 3 from my domain. So there's negative 1 and 3 removed. All other numbers are still in the domain. So I started off it's a function, all real numbers. I recognized it's a fraction. I said the denominator can't be 0. So when is the denominator 0? The denominator is 0 when x equals 3 or x equals negative 1. I took those out and I'm left with my domain. I'll abbreviate with D. My domain goes from negative infinity to negative 1. Union from negative 1. Whoops, that's a negative 1, Coleman. From negative 1 to 3. Union from 3 to infinity. And notice I am using parentheses because I can't include negative 1 or 3 in my domain. All right, let's take a look at an even root example. Okay, let me get my paper turned over. There we go. Okay, I have a function. Okay, so my starting point is, my domain is all real numbers. Unless I find something that's going to remove any numbers from my domain is all real numbers. That's my thinking. I look at my function. Do I see a fraction? The answer is no. Do I see an even root? I do. I have an even root. This is the square root of 3x plus 12. Okay, so I have an even root. Okay, so my radicand must be positive, which means greater than or equal to 0. It can be 0. I can have 0 underneath because the square root of 0 is 0. I can have any other positive number, but I can't have a negative. My radicand must be greater than or equal to 0. Well, let's test my radicand to make sure it's greater than or equal to 0. My radicand is 3x plus 12. When is that greater than or equal to 0? We'll also subtract 12 from both sides. 3x is greater than or equal to negative 12. I'll divide both sides by 3. X is greater than or equal to negative 4. Okay, so now all my x's must be greater than or equal to negative 4. So I'm going to come down to here, and I have to be larger than, I can be equal to negative 4. So I'll put a negative 4 in here, and I'll put a closed circle on that for my number line. All my x's must be larger than or equal to that. So this is my domain. So my domain is not all real numbers because I have an even root. My domain is actually anything from 4 to infinity, and 4 is included. From negative 4 to infinity, and negative 4 is included. hence the square bracket next to -4. Okay, let's do one more example, and let's put fractions together with radicals. Okay, so here in letter D, my J function says 3x plus 2 over the square root of 14 minus 2x. Again, my thinking, I always start in my mind, I always start, it's a function, the domain is all real numbers, and then I look at it, okay, and I say, wait a second, not only do I have a denominator, but I also have an even root. Okay, so I have an even root, and I have a denominator. Okay, so the even root says greater than or equal to 0. The denominator says can't be 0. So the result of this is the radicand must be positive. As we recall in example C up here, the radicand in this case could be 0, but it wasn't in a denominator. In this case, letter D, because the radicand is in the denominator, it can't be 0 because the denominator can't be 0. So my radicand must be positive here. Okay, so let's take our radicand, which is 14 minus 2x. It must be positive. I'll add 2x to both sides. I'll divide both sides by 2. And then I'll rewrite it with the x coming first, x less than 7. Okay, so I started off thinking here it was a function, and then I recognized I have an even root and I have a denominator to deal with. So my resulting domain starts at 7. I'll put 7 over here. Does not include 7 and is all x's that are less. Whoops, let me get a little bit higher for you all. All x's that are less than 7. So here's my number line for the interval, how it looks for my domain. And my domain in interval notation is from -infinity to +7, not including +7. So to wrap it up, you want to be thinking it's a function, its domain is all real numbers unless you see a fraction or an even root, and either of those two things could cause the domain to be restricted.